Unit 3 was all about rules of exponents, okay? Does anybody remember when I have something that looks like this? Okay, good. When I have something that looks like this, what am I going to do with those exponents, Brandon?
Say we do the y's. You multiply the y's together, so it's y, and then you add the numbers on top. You just add them.
Very good.
So it would be like y to the
11. You're right. What we have to do is we look at each of the individual terms. So, for example, x's. We can only combine the x's together. They're still like terms. We also have y's, and we can only combine the y's. And what Brandon was telling us, we add those exponents. So right next to it, will you write add exponents? Okay. What do I do with the coefficients, the 3 and the 5? I multiply them. So let's do it. What is 3 times 5? 15.
That was easy.
What is x squared times x to the 4th? X to the 2 plus 4 is? 6. And y to the? 11. 3 times 5. And that's your answer. Example 2. Okay, example 2. We have 6a to the 4th, b to the 5th, c. If c does not have an exponent, what is the exponent? 1. 18a, b, c to the 6th. So a has an exponent of 1, and b has an exponent of 1. Now this is division. If I'm add the exponents in multiplication, what do I do with the exponents in division? Subtract. So let's write that. Subtract exponents. Okay. But will my exponents always be on top?
No.
No. How do I know where they go? Wherever the bigger one is. Okay, so let's look at these. Let's look at the coefficients first. 6 and 18. Do those reduce at all?
Yeah.
Yeah, what do they both divide by?
6.
6. 6 goes into 6 once, and 6 goes into 18 3 times. Okay, now we're going to look at the a's. I have a to the 1st up here, or down here, and a to the 4th up here. So what is that going to give me? A to the 3rd. And will that be on top or on bottom? On top, because 4 is bigger than 1. So we cancel that one, and we change the 4 to a 3. Let me zoom in on that. Is that easier for you guys to see? There we go. Okay. What about the b's? I have b to the 5th on top and b to the 1st on bottom. So that's going to give me b to the 4th. And will they be on top or bottom? Top. So that b cancels out, and that 5 changes to a 4. And then what about c's? C to the 5th, and it's going to be on bottom this time. So that c cancels out with one of the c's down below. Okay, so let's rewrite everything. I have my fraction bar. What's on top? A to the 3rd and b to the 4th. What's on bottom? A 3. And c to the 5th. You do not have to put the 1 on top. Because we have a and b here, we don't have to put the 1. The 1 is only a placeholder if there's nothing else up there.
the one where you can expand it, huh?
Correct. If you wanted to, you could have expanded it all and canceled everything out. Okay? But remember, I did show you the shortcut. Okay. Example 3. Okay. What property does this look like? Distributive. So let's do it. We're going to distribute x squared to everything inside the parentheses. And then we're just going to multiply. What is x squared times 2x to the third? 2x to the fifth. How'd you get 5? You add the exponents. What is x squared plus 3x? 3x to the third. Good. And x squared times negative 7? Negative 7x squared. And that's your answer. Example 4. 4x to the third minus 2x squared minus 3. All of that minus 5x squared plus 7x minus 6. What is there that I can't see?
The 1.
The invisible 1. So what do I need to do?
Circle it.
Circle it and distribute. Okay, so now, Destiny, now we can take down the parentheses. So that's going to give me 4x to the third minus 2x squared minus 3 minus 5x squared minus 7x plus 6. Okay, now I can combine like terms. Is there any like terms with 4x to the third?
No.
No, so let's just rewrite it right now. What about negative 2x squared?
Yeah.
Yeah, what is it?
Negative 5x.
Negative 5x squared, so that gives me
Negative 7x squared.
negative 7x squared.
Minus 7.
We have a minus 7x here. There are no other terms, so we just rewrite it. And then we have minus 3 plus 6. What does that give me? Plus 3. So that is your answer. Oh my gosh. Okay. Example 5. X minus 5 times x plus 6. What were the two methods I have for this? Box and FOIL. Let's write those down. Box or FOIL method.
Oh, we're going all the way back to the box.
Okay. Raise of hands. Who wants to use box? Who wants to use FOIL? I think box wins it this time. We'll use FOIL on the next one. Okay? So let's draw our box. Okay. We put one of them across the top. I'm going to choose x minus 5. And we put one of them across the side, x plus 6. Okay. Then we multiply. X times x gives me x squared. X times negative 5? Negative 5x. 6 times x? 6x. And 6 times negative 5? Negative 30. Okay. I can combine like terms here. So that's going to give me x squared. 6x minus 5x. Positive 1x minus 30. So do remember, guys, that after we do all of our multiplication, those two diagonal terms, we add them. Okay? So that's how we get positive x. Do not multiply them, okay? Yes?
Oh, never mind.
Oh.
It wasn't.
Example 6. 3x minus 2y, all of that squared. What should I do first?
Write it all out.
Write it all out. Or what did I call it? Expand it. So let's expand this. This is the same as
3x
2y times
3x
2y.
boxes.
Okay, you can use box or foil. Since we did box on the last one, I'm going to use foil this time. Okay? What? 3x times 3x, what does that give me? 9x squared. Because it's an x to the first times an x to the first, and you add those exponents, which gives you a 2. 3x times negative 2y. Negative 6xy. Negative 2y times 3x. Negative 6xy. And negative 2y times negative 2y. Positive 4y squared. Am I done? I can combine like terms. What is negative 6xy minus 6xy? Negative 12xy. So my answer is 9x squared minus 12xy plus 4y squared. Okay. Example 7. 10x minus 3x, all of that times 4 minus 6x plus 9x.
No.
Very good. First thing I have to do is I want to distribute that negative 3x. Please remember the negative. And then let's distribute. So that's going to give me 10x. Negative 3x times 4, negative 12x. Negative 3x minus 6x. Positive 18x squared plus 9x. Combine like terms. Where are my like terms here? 10x, negative 12x, and 9x. I like to put the x squareds in front though, right? So let's put the 18x squared in front. And then what is 10x minus 12x? Negative 2x plus 9? Positive 7x. 10x minus 12x is negative 2x.
So pretty much 10 minus 12 is negative 2.
Negative, and then negative 2x plus 9x is positive 7x. Yeah. Okay, these were tricky. The sum of two binomials is 4x squared plus 9. If one of the binomials is negative 5x squared plus 3, what is the other binomial? Okay. Yes, that's what we're going to do. You're right. Okay, the first thing we're going to do is let's read the problem. Let's write it all out as we read it. The sum of two binomials. So let's write those binomials. We just don't know what they are yet. And what does sum mean? Add. So we are adding them together. I did not leave myself enough room there. Is, so that means equals 4x squared plus 9. Yes. It's a plus. If one of the binomials is negative 5x squared plus 3, so we can fill one of those in to negative 5x squared plus 3. So now what we want to do is we want to move this whole thing to the other side. So what are we going to do? We're going to subtract it. So minus negative 5x squared minus 3. Oh, plus 3. Sorry. So we're subtracting the whole thing. Okay. Now, this whole thing is being subtracted from itself, so they just cancel out. So we are left with our blank binomial equals. Now what do I have to do with that negative? I have to distribute it. So when I distribute the negative, what happens to that negative 5x?
Positive 5x.
It becomes a positive 5x, and I'm going to use a different color. And what happens to that positive 3? It becomes a negative 3. Distributing the negative changes the signs, right? Okay, so now let's combine like terms. 4x squared plus 5x squared. 9x squared.
Hey, don't touch my thing, sir.
And 9 minus 3? Positive 6.
Whoa, we
And that's the answer.
only have 3 minutes left.